Okay, welcome, Claudia and Sean and Zaida, and hopefully we'll get a couple more coming. And welcome to Wednesday webinar, a little later than usual, because again, with the test, I wanted to make sure that everyone's finished the test before they had to worry about the webinar. And there might be a couple people, I saw one person in there taking it at our college, but most people are pretty much done. So hopefully it went okay. It will be curved, by the way. So, it's not time to start thinking about it. And I'll be grading it over the next few days. That's the plan. And then if I can get the computer to work, there's some issues. I'll do a little vocal recap of your score. I'll also put the key online. As soon as I get everyone's test from every proctor, then I'll be ready to put the key online. So that'll be up there eventually. But the plan today is that we have two things. And the first is chapter 10. And chapter 10 is very much like chapter 9. So it's hypothesis testing. But for chapter 10, what we're going to do is we're going to be looking at hypothesis testing for a difference between two population means or two population proportions. And there's different ways of looking at that. And I want to kind of discuss some of the details of that. The rest of it is just the same as hypothesis testing you've had before. So a lot is just the same as chapter 9 with a couple extra details. Then what I want to do is I want to start talking about the project, because the project really is about chapter 10. So as soon as I'm done talking about chapter 10, then we'll be able to talk about the project. So that's the plan in terms of order of events. Let me ask you right now if there's any questions, general questions. I'll be happy to answer right now before we go on to new material. Give you a moment to think about your questions. Any questions? Any questions? We got a one in the chat. How can you tell when to use a T? When do you use test? Use test or t-test? I'm not sure.
Sorry, it was the z-test. Or
okay, so
like the ones that are in the calculator for this chapter and for the last chapter.
Right. So z-test you only use when you know the population standard deviation, which is in the real world never. T-test you always use when you are testing for a population mean, a single population mean, and then we'll be using a t-test. So only in the very rare case where you know the population standard deviation, which in all practical purposes doesn't happen. So you'll notice I did not test you on the t-test actually because it's not that useful, but it's just a little in passing. So the good thing about the t-test is it helps connect. It's kind of a stepping stone to connect the normal distribution with hypothesis testing, because Z stands for normal, and then T is a modification of normal. You don't have to know all the math, but that's kind of why we do it in the first place, is kind of see as a stepping stone.
So the T stands for modification?
I don't think T actually stands for anything. I mean, if it was modification, it'd be an M. But the reason why you use a T distribution, not a normal distribution, is that the standard deviation is unknown. So there's an extra bit of error in using the sample standard deviation as the population standard deviation. And the T handles that error. And the math is very hard. So I couldn't even explain it to the highest level student at our college because it's really hard. So we're not going there. So the main thing is you only use a Z if you know the population standard deviation, which is pretty much never. And the main thing is to know when to use a t-test and when to use a one-prop z-test. And one-prop z-test is for the yes-no survey question. And the t-test is for the quantitative, when the answer is a number. That's more important. Hopefully that makes some sense. Okay. So what I thought I'd do is we'll do a little current event. I like to bring in current events if I can. And here's a question. What do you think? Do you think Americans like Canada or Great Britain more? Or do you think there's no difference? Any thoughts? Okay. We got a split, Canada, Great Britain. Okay, well, what we can do is we can see. And you know what that means? It means we're going to go into the news and look at it. So let me share the screen. And hopefully you can see that. Actually, it doesn't say that you can see it. Let me stop the share. Let's try one more time. There we go. Now you should be able to see it. Okay, so this is an article. I like Gallup because it gives you the numbers, which is always good. Americans like Canada most. North Korea least. Do they know that Americans like Canada most? What do you think? No, they can't know about all Americans, but maybe they have evidence to show that they like Canada the most. And in particular, what my question was is, do you think there's a difference between Canada and Great Britain? So we can go in here, and we can see that 94% of their sample, this is obviously the sample because they don't know the population, like Canada, and 89% like Great Britain. Any questions on that? What we want to do is we want to find out, is there a difference between the two? Right? I mean, those numbers are different, but with just a sample, maybe they're close enough that the whole population of America might be the same. Does that make sense? So in this case, this is a hypothesis test for two different proportions. The proportions of Americans who like Canada and the proportions of Americans who like Great Britain. So this doesn't fit into the one prop Z test. It does not fit into the t-test because it's clearly not quantitative. But it's not a one prop Z test because we're looking at two proportions. So we're going to be using a two prop Z test. Does that make sense? So by the way, as always, with Gallup, if you go down to the bottom, it will tell you they surveyed 1,044 people. So for this particular one, we're just going to say 1,044 were asked, do they like Great Britain? And 1,044 were asked, do they like Canada? So I'm going to put some, I want to write things down, 104, and our percentages, just to remember, were 94 and 89. And what I want to do is I want to go back to share the Paint desktop so that we can start analyzing and doing hypotheses. So let me do that. Okay, so the first thing, and this is going to be the same thing that we always do, is the first thing is you write down your null and alternative hypotheses. So in this case, notice that the questions are, do you like Great Britain? And do you like Canada? Okay? And let's just let Great Britain be the first one and Canada be the second one. So we're going to have H naught. Notice, by the way, that's a colon and not an equal sign. I saw on the exam, some of you put equal signs instead of colons, and that's not appropriate. And then it's P1 is equal to P2. So this is kind of the new piece of what we've done, where P1 is a proportion of Americans who like Great Britain, and P2 is a proportion who like Canada. Any questions on that? And H1 is that P1 and, lowercase P1, for now I'm going to write equal, but I'm going to make it a not equal to P2, just for typing reasons. And now I'm going to put a cross through there. Is not equal to P2. So this is a two-tailed test because we want to find out if there's a difference. Any questions on that? Okay, and probably a good old level of significance, 0.05 seems about right. Because it's just kind of newsy stuff. When in doubt, 0.05 is a good one. Any questions so far? Okay, notice that, I don't know if you remember or not, but they told us there were 1,044 Americans surveyed. That was in the Gallup article. We also found out that, let me write that using pencil. P1 hat. We put a little hat over it to indicate that it's a sample proportion. Okay, we don't use Greek like we do mu, because Greek for P is pi, and it's just, that's confusing. So we use we use hat instead. So with the hat, it means sample. Without, it means population. And P1 hat is going to be 0.89. Actually, I can type this one out. Okay, and P2 hat was 0.94. Any questions so far? So we're going to see.
Yes, why did you use 94 as P2 and P1 since we're doing P1 not equal to P2?
That was because P1 was a proportion who like Great Britain. So I had to pick one of them, and I chose the first one to be Great Britain. And P2.
But there's no actual rule that you have to make the smaller one P1?
No, there's no rule about it at all.
Okay.
But you have to be consistent. You have to know which one you're calling. So it's good to label like I just did, so you know what you're talking about. Okay. And it turns out when you have the not equal to, it really doesn't matter. If you have a one-tailed test, then if you switch it, it's going to switch the inequality. Does that make sense? So if we wanted to think that Canada had a higher proportion than Great Britain, then notice because of the way we chose it, we would have a less than, because Great Britain is less than Canada, is the alternative hypothesis. Does that make sense, Claudia?
Yes.
Okay, good. So as long as you know what your notation means, that's the most important thing. Any questions so far? Okay. Just a note, because the calculator is going to want it, x1 is going to be equal to n times p1, or 1,044 times 0.89. And let me quickly calculate that. That's about 929. And x2 is equal to 1,044 times 0.94. And that's about 981. We're going to need these for the calculator. Any questions on that? So x1 is the number of people the number of people surveyed who said they liked Great Britain, and x2 is the number of people surveyed who liked Canada. Any questions so far?
So the formula to solve x1 is always going to be n times p hat 1 and n times p2 hat.
Yeah, and that's just from common sense. You want to find out the total number of people who said yes, you take the total number of people times the percent or proportion who said yes. Does that make sense?
Yes.
That's not a fancy formula, that's just like basic math, right? Do you see that? That's just how proportions work. Okay, so now I want to use my calculator. All right, so in my calculator, let's just clear whatever I used to have. I'm going to go to Stat, you're used to this. Then I'm going to go over to Tests. I'm going to use a test we haven't used before. Any guess?
2-prompt z-test.
Yeah, it's 2-prompt z-test. We have 2 samples now, right? Or 2. That's the sample. The sample for people who were asked about Great Britain and the sample for Canada. We're comparing 2 things. They're both yes/no questions. That's why it's prop. Notice it's Z because if we take the x1 and x2, they're both bigger than 5. If they're not bigger than 5, you can't even do this. It's not even allowed. So I'm going to do 2-prompt z-test. And we just put in the numbers. At this point, it should be basic because you just read off what you got. So x1 was 929. N1 was 1044. So they don't always have to be, N1 and N2 could be different. In this case, they're the same. X2 was 981. And N2 is also 1044. Notice we have a 2-tailed test. So I hit enter on the not equal to. Color I always ignore. Any questions before I hit enter? Now I always recommend you kind of following along with your calculators too. Okay, hit enter.
You enter for n to the population again?
What's that?
You enter the for n to the population again?
Yeah, well sometimes there'll be different numbers. So remember there were 2 survey questions. One is, do you like Canada? The other is, do you like Great Britain, right? Or I guess one is, do you like Great Britain? The other is, do you like Canada?
Okay.
So had they asked a different number of people for each of those questions, you'd have different ends. But in this case, they didn't. So they can be different. Okay. And there we have it. So notice that Z is negative 4.0 about, or 4.1. That's a really small Z-score, right? That's like super outlier, which means that our p-value, what is our p-value?
Is this
Important.
statistically significant?
But what number is it?
Oh.
0.9147.
No, that's not the p-value. That's why I'm asking.
4.6?
It can't be 4.6 either because it can't be bigger than 1, right? It's a probability.
Oh, yeah.
And what you have to notice is why I stopped, and this is a good example because this E negative 5, remember what that does?
Oh, yeah, you move it to the left 5 times, don't you?
Yeah, don't forget to read that E or it totally changes everything. So it means it's 0.000046. And that's tiny, tiny. Any questions on that? Okay, so let me go back to my kind of painting area. Notice that our p-value was equal to 0.000046, which is minuscule. You don't even need a level of significance because it's clearly small. So we can say, and hopefully, what are the first few words that we're about to write down, they're about to say? What's the conclusion?
Wouldn't it be like we have statistically Significant evidence.
Good. We have statistically, sorry, I don't type as fast as you talk, but that's okay. Statistically significant evidence to conclude that the population proportion of Americans who like Great Britain and what do we say? What are the next few words?
Is not equal to?
Yeah, is not equal because it's a two-tailed test, so it's not equal to the population proportion of Americans who like Canada. Any questions on that? Okay, and if you want, you can say we have strong statistically significant evidence because P is so small. Notice I want to highlight a few things. One is this population, that needs to be there, population proportion, okay? Don't refer to the sample. This has nothing to do with the sample. It has to do with all Americans now. So we really can talk about all Americans. Okay? Doesn't mean we know for sure, but we have statistically significant evidence to make a conclusion about all Americans and not just the 1,044. Does that make sense? I noticed because I was looking at some of the tests that got turned in, some of you aren't putting that word population in. And that's an essential word. The other thing to note is this is a yes-no question, so it has the word proportion. Okay? If you put the word mean here, that would be wrong. Similarly, if you have a quantitative question, a number question, then use the word mean and don't use the word proportion. Is that clear? So a lot of people had that trouble in on the test, and it might have been because of the note card, which only had your one example. Question?
Yeah, what if you put X?
What do you mean X?
Yeah, instead of P or U for mean.
In the words, you mean?
Right, right where it says the H1, instead of putting a P for proportion or mean.
Oh, that'd be wrong. That'd be wrong. So it's definitely P1 and P2. Does that make sense? Because we're talking about a proportion. P stands for proportion, and X doesn't really stand for anything. Right? Unless it was a question about xylophones or something. Yeah, so it definitely needs to be P. And if it's a question with a quantitative study, it can't be P. Then what must it be?
Mu.
Mu. You see? So it's either going to be a P or a mu. And in this chapter now we have these subscripts, P1 and P2, because we have two samples instead of just one. Any questions on that? Any questions? Okay, I think I want to go to another type of problem. I have some examples to look at. Let me do this. Hopefully this is big enough. Not need to make it bigger. Just a minute. And let's go in here. Oh, that didn't work. Let's try one more time. Okay, so here we go. So are left-handed people better mathematicians than right-handed people? Sounds like a good little question, right? What do you think? Maybe, maybe not, right? Okay, 35 randomly selected lefties and 40 randomly selected righties took a math test. The lefties scored an average of 72%. Standard deviation was 13%. The righties scored an average of 68%, and the standard deviation was 13%. So find the test statistic and p-value. State the conclusion in the context of the study and interpret the p-value. Let's interpret the levels. We're going to interpret everything, basically. And I may not write it all out, but I'm going to at least say it. So the first thing is we need a null hypothesis and an alternative hypothesis. So let's start there. Notice that there are two samples here, just like before. So we're going to have an H naught, but the difference here, for these two samples, the survey question is, what did you score on the test? Not, did you score on the test? Does that make sense? So we're talking about means and not proportions. So for this one, we're going to say mu, because with means, we're talking mu. Mu, how about lefties, is equal to mu righties. Any questions on that? Then we're going to have an H1. Now for H1, it's going to be the same idea, but the key word here is our left-handed better. If you're better, you score higher, right? So that's going to be mu L is greater than mu R. Any questions on that? Any questions? Okay, so now notice the difference in this chapter and the last one is now we literally have two different means. Okay, and they're both unknown, and we want to see if one's bigger than the other. Whereas last week we only had one mean that was unknown, and we want to see if it was bigger than something that was known. Does that make sense? Okay, so now we've got that. So just to note, we can look at these numbers. I like to write down the numbers. It's probably a good idea. So what we can say is, first thing, 35 randomly selected lefties. That's N1, or N, let's call it NL. Okay, and then we have, for the righties, there were 40 of them. So as you asked before, the numbers, the sample sizes don't have to be the same. You see where here we had a different number of each. Okay, then we had the lefties score an average of 72%, and that is going to be X1 bar. And it doesn't matter whether you call it 0.7, whoops, whether you call it 0.72 or 72, because units don't matter as long as you're consistent. So I'm going to call it 72. And then similarly, X2 bar. That's a terrible 2. It's hard to draw with a pen on a computer. 2 bar is equal to, so again, the righties average 68. And then we have, I'm going to write it this way because it's too hard to type with it this way, S1, the standard deviation, oh sorry, SL, standard deviation for the lefties, was equal to 13. And the standard deviation for the righties was equal to 13 also. Any questions so far? Okay, so now that we have that, we have all the stuff we need. Guess what we do now?
calculator?
Yep, we go to our calculator. And hopefully you get that the calculator is really important in this class. Okay, so we go to our calculator. Oops, I lost it. Uh-oh. Okay, so I'm going to clear what I had. I'm going to go to Stat, Tests. What test do you think I'm going to use now?
Two-SAM Z test?
It's a good try, but Z is when you know the population standard deviations, which we don't. So it's T-test, two-SAM T-test. Again, you're never going to know the population standard deviations. In the real world, it just doesn't. And then I hit enter. And now I just type in my numbers. X1 bar was 72. 72. X1 was 13. N1 was 35. X2 bar was 68. SX2 was also 13 in this case. And N2 was 40. For our test, we have a greater than for our hypothesis test. It's a right-tailed test. In our class, always no for pooled. Because in the real world, it's pretty much a good bet that it's just going to be no. And then calculate. Any questions before I click calculate?
What's pool?
Pool is if you have certain criteria about knowing the population standard deviations being the same, then you can pool, but that just doesn't happen. So we're just going to do no.
For our class, it's always going to be no.
Yeah. Just no unpooled. Would you want to jump into an outdoor swimming pool tonight in Tahoe?
Maybe.
Really?
There's the polar bears.
It's cold. I wouldn't. I would say no. I would say no to that one. Okay, so it's a no. You hit calculate, and it gives the stuff we need. It gives a test statistic, which is about 1.3. The p-value is about 0.09. Any questions on that? Those are the main things that's the main thing you need to know. Now I can do back to my writing board. And let me remind you, P was 0.09 because that's what we need. And now it's time to state our conclusion. So what do you think for the conclusion?
It's not statistically insignificant.
Yeah, statistically insignificant. Evidence. Notice I even said use 0.05. So on this one, yeah, I need that. To make a conclusion about the population mean math score for lefties being greater than the population mean math score for righties. Any questions on that? Are you seeing how this is very similar to what we did last week? It's just kind of an extension. We now have two samples, but it's basically the same stuff. Any question? I'm not going to type it all out. It's a lot of typing, but for the p-value, same idea, is that, as we had last week, is that if the population mean test score for math for lefties was the same as the population mean math score for righties, and if we did another study in this case 35 lefties and 40 righties, then there would be a 9% chance. And we look at this, notice that lefties did 4% better. Do you see that? They scored 4 higher. So there'd be a 9% chance that the lefties in the new study would score at least 4% higher than the righties. Any questions on that idea? So it's the same as what we did last week, but now there's just 2 studies, or 2 samples. Any questions on this? Okay. And for level of significance, same idea as last week. It's the probability of a type 1 error. So if lefties and righties were the same, in order to have the same average test score for the population, and if we did another study of 30 lefties and 40 righties, then there would be a 5% chance that we'd end up concluding that lefties had a higher score than righties for their population meetings. So it's the same as what we did last week. Any questions on that? Okay, let me do one more example before we talk about the project. And this, by the way, should help you a lot with the project. This example and the one I'm about to do and the one I just did. So let me do this one, just a second. The table usually looks a little weird when I do a copy, but sorry about that. Yeah, so that's a table of numbers. Sorry about some of the vertical lines showing and some not showing. That's just weird copying. All right, so the question is, are people better listeners if they do not have use of their eyes? Okay, the typical psychology kind of thing, right? 12 volunteers were first given 100 words to remember while they were looking at the person speaking. Then they were given 100 words while blindfolded. Each time the participants were asked to write down as many of the words as they could remember. The table below shows the outcome of the study. So let's do everything we need to do. So basically all this says, do the hypothesis test stuff. Any questions on the questions? Okay, this is profoundly different than the last one. And it may look similar because we're comparing looking versus blind, and they're both quantitative. Do you see that? Anyone know the difference? Any of you all see the difference between the two? The main difference? Okay, I'm getting a lot of silence. All right, the main differences in the last one. The lefty, the first lefty, for example, and the first righty had nothing to do with each other. They were just individual people. They weren't like coupled or anything like that. It was just some lefty and some righty. Here, it's the same person taking the test while looking as taking the test while blind. Does that make sense? So we call this paired. So if these first two numbers that we have, the 14 and 17, come from a same paired thing, then it's paired data and not what we call independent data. The last one was independent. This is paired or dependent. And when we have that, we handle it very differently. So let me write down. Of course, we start the same, H naught. Always start there. And now what we're going to do is we're going to be looking at the difference between the two individually. So we're going to have mu sub D. Notice D doesn't stand for looking. It doesn't stand for blind. Any guess on what it stands for? No guesses?
Reference?
Difference. Difference. Because we want to find out, we want to look at the individual differences and we're going to create a new one sample test using the differences. So we're going to go mu sub d equals 0 because if they're the same, then the difference is 0, right?
This is like the example you put on the practice test, correct?
Might have been. I'm not sure. I don't remember. Practice test was a while ago. So, and then H1 is the same idea, but it's going to be mu sub d is, in this case, we'll look at it in a bit, but at least we know it's going to be mu sub d. Okay, so take a look. This is where you want to look at this. So first thing, we're going to go looking, D is looking minus blind. I better write this down. You got to pick one of them, and let's pick that. You can do blind minus looking, but it'll be easier this way because it'll look like what the calculator's asking. So now think about it. If you're a better listener, when you're blindfolded, then looking minus blind will be a negative number. Does that make sense? So that tells us that we're going to have a left-tailed test, or a less than 0, because negative numbers are less than 0. Any questions on that? Okay.
Repeat the last part, please.
What's that?
Repeat the last part. Why is it less than 0?
Okay, because take a look. If you're better when you're blind than you are looking, and you take looking minus blind, you'll get a negative number. So for example, this first person was better blind than looking. They got 14 words for looking, 17 for blind, right?
Right.
So they were better blind than looking. If you take 14 minus 17, you get negative 3, right?
Mm-hmm.
That's less than 0.
Okay.
So that's why it's less than 0. I like to do a test, just kind of one number that works and see if you get negative or positive.
Do you always test just the first number in these kinds of examples?
It's not always the first. It's one that works. So we want to find out if they're better listeners if they don't have use of their eyes. So notice the first one worked because the first person was better without the use of their eyes. Do you see that? So you test one that worked. Right? So you wouldn't test this 4-3 example because that was better looking than blind. Do you see that? So you test one that works. Now I see it. Thank you. Yeah, test one that works. Okay. So the next thing we do is go to our calculator. And this is going to look very different than what we've done before. So follow along, use your calculator if you can. And let me go to share. Okay, so I'm going to clear out what I had. First thing, I'm going to go to stat. Ah, shoot. That's not what I wanted. Keeps doing it. Just a minute. This one. Okay, so I'm going to go to stat. I'm going to go to edit. I'm going to clear out L1. I'm going to clear out L2. Hopefully you know how to do that by now because we've been doing that for a while. And I'm going to type in all the numbers for L1 for the lookings. 14, 23, 15, 37, 4, 19, 22, 51, 37, 18, 16, 22. I think that was it. Yeah. Okay, and for L2, I'm going to type in the blinds. 17, 25, 20. And then 37, 3, 29. 24, 53, 35. 20, 19, 22. So you've done this before where you put in numbers, right? Okay, then I'm going to go to stat. Not stat, sorry. Then I'm going to go quit. Second quit. And now I'm going to go second one. minus second 2. Notice it's L1 minus L2. Then I'm going to hit the stow button. And that means store it into. And I'm going to go second 3. So what I'm going to do is I'm going to store the differences into L3. And I hit enter. And notice it just gave me the differences. 14 minus 17 was -3. 23 minus 25 was -2. Those were the numbers. This is the data of differences. Any questions on that? Then we go ahead and we go to stat, tests. And this may look weird, but this is just one sample now because it's a sample of differences. So we'll do a t-test. We have data. U0 is 0. Our list is not L1, it's L3. Freq is 1. And if you remember, our hypothesis was a less than. We go to calculate and enter. And what do you notice?
P is less than
What's that?
5.
Wait, one more time.
P is less than 0.05.
Yeah, the p-value is 0.0176. And that is less than 0.05. Okay, I'm just going to say it because it's the same stuff we've been doing. So there is statistically significant evidence to conclude that the population mean number of words that people can remember if they're blindfolded is greater than the population mean number of words they can remember if they're not blindfolded. Does that make sense? So I'm hoping at this point you get how the conclusion works, because it's the same idea. Any questions at all? Any questions at all on this idea? You notice it's very different because this one was paired and the other one was independent. So the way you use your calculator is very different. Any questions at all before we talk about the project? Okay, let's go to talk about the project. Notice I didn't need quite as much time to talk about this chapter because it's kind of the same. Is it feeling the same? The same as last chapter? Okay, I mean, there are slight differences, but it's basically the same. Let me do this. Not gonna like it, but I'm gonna do it anyway. And let's stop share, and let's reshare. Okay, so you know this screen. All right, so what I want to do, I want to show you, there's different ways of getting to it. I'm going to use syllabus.
Forget the secret word.
I'll get it at the end. You want me to do it now? I can do it now. So the secret word is actually a number, but I want you to spell it out. So I guess I need to reshare for that so I can type it in. So the secret word is 2. Make sure you spell it out. Don't write the number 2. It'll get counted wrong. And that's because we're looking at 2 samples, right? Right? 2 populations or 2 answers to the question. So 2 is the right word for this particular webinar. And it's going to work for the project also. So let me go back to New Share. And let's go to there. Hopefully you know how to get to the syllabus. If you go to project 2, so I'm going to read through this and I'll talk about this. So the purpose of project 2 is to use confidence intervals and hypothesis testing to support or show lack of support for a research project. Okay, very different than the last project. You must first decide what you're interested in researching, and then you design your study to collect your data. Then analyze it and see whether you're supporting the hypothesis and see what the confidence interval tells you. So the key here is the first thing you do is write down your null and alternative hypothesis. That's how you start. That's number one. Actually, the first thing is get a partner. So make sure you have a partner. Then you write down your null and alternative hypothesis. Agree on it with your people, with your partner or partners. And then you can start doing everything. So then you're going to write down your survey question to address the null and alternative hypothesis or survey questions. You're going to have to do a either a 2-sample t-test or a t-test with paired data. Okay, that's your choice, but it needs to be quantitative, and it needs to be that, you know, comparing two things. Any questions on that? Okay, so that's really important that you got two things going on. It's either going to be paired or not paired. And that's up to you, but if you do paired with your study and then calculate not paired, that's not okay. So make sure you know the difference between paired and not paired, and that's kind of what I just showed you just now. That's why I'm doing Project 2 discussion now, because now you're ready. Does that make sense? I recommend doing the whole client thing like you did last time. Decide who you're working for. It helps you decide the focus of your project, how you're going to write it. And if nobody be interested, it's not a good project. So having a client helps out. Okay, this is very different than Project 1. The first thing is, I don't care how you collect your data. If you want to do convenience sampling, you can do that. You don't have to do a survey. You could collect data online if you want. You just need to get data. Does that sound fair? Okay, but you have to, if you can get the data for the entire population, then this won't work, because if you can get the whole population pretty easily, there's no reason to do a hypothesis test in the confidence interval, because then you just know. Does that make sense? So you have to make sure that it's something you can't get an entire population of, so you can get a sample. And again, you could do it by survey, or you could just go find data, go online and collect something. You know what I mean? Or you can measure things. It doesn't have to be people either. You could do a measurement. For example, in Tahoe, Claudia, I know you're a Tahoe person. Sean, I forget whether you are. I know, Zaida, you're hard because you took your test in Mexico. I don't know where you live in.
Yeah, but I live in Tahoe.
You live in Tahoe. Okay,
Yeah.
So people have done it, for example, on comparing the clarity of the lake on the North Shore versus the South Shore. Does that make sense? And that data is available in terms of a sample. You're never going to get populations. Sean, you're in the foothills, McCollum Hill. Okay, so sorry if you don't understand when I'm talking about lake clarity in Tahoe, but that's our big thing in Tahoe, right? So that data is available on plenty of websites where you can go find that data and grab it. Does that make sense? So you can grab data that doesn't have to be a survey of people answering a question, right? Does that make sense? So, but it has to be interesting, something that someone would care about. Any questions on that? Okay. So you have to tell me the sampling technique. Again, you could use convenience sampling, that's fine. Whatever you want to do that way. The variables must be quantitative and subtractable. In other words, if you're going to ask 2 survey questions, don't ask how tall are you and how much do you weigh? Because it doesn't make any sense to say people are taller than they are heavy. Does that make sense? So make sure that when you're asking 2 questions, if you're going to ask 2 questions, or taking 2 sets of data, that they're comparable. If you can't compare them, it's not a good project. Does that make sense? So finding out the nitrogen concentration in the South Shore versus North Shore, well, that's very comparable because it's both nitrogen concentration. Okay, or something like comparing, for example, do women have higher GPAs than men? That would be very comparable. And that would be an independent sample because there's no pairing for women and men. Does that make sense? Okay, so sometimes it's independent, sometimes it's dependent. And if you're not sure, what can you do?
Survey?
No, if you're not sure whether it's independent or dependent?
Oh, you can,
Should I tell you? You could post on the project discussion forum and ask, and I'll tell you. And what I strongly recommend doing is posting your null hypothesis and your alternative hypothesis on the project discussion forum within the next 5 days or so that I could look at it and let you know whether it's a good start. Okay, because that's the first thing you're going to do. So post it in symbols and in words. And then I'll let you know, and also by posting, other people have an idea what can work and what can't work. And you'll be able to see each other's. Does that make sense? So it's a way of communicating with each other and sharing. And sharing is important. So I recommend in the next few days, get with your partners. You don't have to use the same partners as used for Project One. I know there's a couple people that are looking for partners. If you're looking for one, post in the project discussion forum that you're looking for one. If you can take one, please take that person. Don't make someone else suffer by themselves, because it's a horrible penalty to do by yourself. So, be nice. Does that make sense? Okay, you must use a spreadsheet. You must use a spreadsheet. So I want to show you something. I'm going to show you the spreadsheet. Might take a moment, but not a long moment. Okay, so this is the spreadsheet that I made. If you don't use this one, it's going to be really hard, by the way. Okay, don't think you can do this with Excel. You cannot use a calculator. You're not allowed to do that. So what you do here on the bottom, you'll see 2 var stats. Click that tab. And then it's very easy once you have your data, you just type it in. I just typed in first and second. If you want to name it, you can. But I try to make it easy by calling it first and second. And just type in your numbers. So I don't know, it might be, the first thing you want to do is erase whatever was there. I want to, one more time, backspace, that's it. And then you just type in the numbers you've got. I don't know, the first might be 34. I'll pretend like I actually had a survey. And maybe 24, 55, 77, 18. Pretend like I had a real survey. And then for the second, you type in your numbers. I tried to make it easy. Do you agree this is easy so far? By the way, how many do you think you're going to need? Based on what we've been doing the last couple of weeks. Huh?
30.
More than 30. Not 30. More than 30. 31 is fine. So more than 30. Okay, so I'm not going to type in all these numbers but you're going to. Does that make sense? And then you have to know how to use your eyeballs. And look over. And you're going to have to decide, is it independent or is it dependent? And everything's there for you. Any questions on that?
Do we have to show graphs this time?
No graphs. Again, don't get it confused between Project One. The focus on this project is the confidence interval and the hypothesis test. Got it? The other bit is right here or right here, depending on whether it's independent or dependent, standard error. Do you remember what that is? Okay, so hopefully not only do you remember what it is, but you remember it in detail. Remember in the standard deviation on Project One, I had you write a whole paragraph? You're going to have to write a whole paragraph on the standard error. It's huge. Standard error goes throughout the entire paper. So it helps you with the confidence interval. It helps you with the hypothesis testing. It tells you whether you have reliable data. Standard error is important. Okay. When you go to the project requirements, because I realize a lot of people have trouble on standard error, I create a video. So I'm not going to do the video with you now, but you can watch the video. And it gives you some suggestions on what standard error is all about. Does that make sense? If you don't watch the video, you're foolish. So I strongly, strongly, strongly recommend you watch the video. Okay, any questions so far? Okay, in the project, you're going to be talking about the confidence interval for the difference. This entire project is about the difference. The word difference better be in there like a dozen times in your paper. Okay? And in particular, population mean difference is what you're talking about, right? Because the confidence interval and hypothesis test are both about the difference. They're not about individuals. So when we looked at this confidence interval, it's for the difference. Don't even bother looking at the confidence intervals over here or anything else over here. Maybe the means individually, that's about it. Everything else is not very important. It's really what it's all about is over here, these two. And it's going to be whichever one, only one will apply depending on your project. I want you to copy and paste the one that applies. So you're either going to copy and paste this guy into your project, or you're going to copy and paste this guy in. You need to show that so that you can prove to me you use a spreadsheet. Or I will take off a lot of points, huge amounts. So that needs to be in your project. It's not hard to do, but it has to be there. Got it? Okay. Just a few notes. Let me go back to the requirements. So for the confidence interval, don't treat it like just an assignment. This is like full paragraphs on the confidence interval and the interpretation. Okay? Don't just say there, with 95% confidence, we can say that the population mean difference is between these two numbers. Okay, that's how it looks on a homework problem, right? Or an assignment. Instead, go into why you care, whether that confidence level is the right confidence level. 95%, are you okay having a 5% chance of being wrong? Does that make sense? And are you okay with the width of the confidence interval? If you want it to be narrower, then you're going to go to 90 instead of 95%. Okay, so you could play around. It's very easy on the spreadsheet to go and take that 95%. Right now, that's 95%. To make it 90, you just type 90 and hit enter, and now you have a 90% confidence interval. So it's very easy to look at them, and you can compare and write the comparisons up. Does that make sense? Why you choose 90% versus 95%. Or maybe you want to be very confident and choose 99%. And look at the interval, and if it doesn't give you any information, that's not going to help. Does that make sense? Okay, any questions on that? Okay, p-value. Yeah, question?
I do. I'm sorry, you said you have to have a null hypothesis. What was the other one? Or
alternative hypothesis.
Alternative.
H naught, H1, they always go together, right?
Yes.
Yeah, so of course if you have H naught, you have to have H1. Wouldn't even make sense if you didn't. Okay, for the hypothesis test, so there's an order at which you do things. The first thing you do is you write down your hypothesis, your null hypothesis, alternative hypothesis. The second thing you do is you talk about the type 1 and type 2 error ramifications. And if you remember, that was on the test today, right? Or yesterday, whenever you took it. So what are the ramifications? Who gets harmed by it because of a type 1 error? Who gets harmed by a type 2 error? Okay, then you say which is worse. If the type 1 errors and the type 2 error is about the same amount of harm, use 0.05. If the type 1 error has a lot more harm than type 2 error, then use 0.01. If the type 2 is a lot worse, then use 0.10. Does that make sense? I want you to evaluate it and write about it. Okay, there's a lot of writing in this hypothesis. Then what you're going to do is collect your data. So you can do this before you do the survey. Does that make sense? Before you do the survey, you have your null alternative hypothesis and you look at the type 1 and type 2 errors. Then you do the survey, okay, or collect your data, depending what you're doing. And then once you've collected your data, you type it in a spreadsheet. And then you look at your p-value, because you already decided on your alpha. You can decide whether you reject or fail to reject. Does that make sense? And then make your conclusion and talk about, don't just write 1 or 2 sentences, but full paragraphs about the p-value, about the level of significance. So in the p-value, you're going to have this probability. Well, is that a high probability? Is it a low probability? Who's going to react to it? How is your client going to be affected? Does that make sense? Are they going to say, well, yeah, you got a 40% chance of this happening? Well, that's like really common. So nothing special happened. Does that make sense? Or maybe you have a 2% chance of it happening, and that's pretty special. Does that make sense? Okay. Same thing with level of significance. Talk about it. What kind of harm might be done? Okay. Again, don't make it look like a homework problem. Full paragraphs, not 1 sentence. Any questions on that? So a lot of writing for this. Okay. Then, again, look at your standard error. Right? And decide whether your standard error was small enough or not. Okay. Similarly, for the confidence interval, was your standard error small enough? Were you able to have a useful confidence interval with a decent level of confidence? If you were, then you should be satisfied with the standard error. If you're not, you're not. So again, all through this, you talk about the standard error. Okay, this last part is a small part about the project. These 2 bullets, notice these 2 bullet points here, this one and this one. Notice how long they are? That's most of the project. So focus on those 2. Most of your pages in the project should be the confidence interval hypothesis test. The rest is like small stuff. Does that make sense? Just a note, you're going to have an introduction since it's a paper. The introduction usually talks about why you care about the project, why it's important, that kind of stuff, why you chose your null and alternative hypotheses. And then you're going to have a conclusion. And one of a litmus test on the conclusion is if you could have written your conclusion before you even looked at your data, it's a poor conclusion. So the conclusion are the highlights of the results of the data. So the highlights of the hypothesis testing that happened, the reject or fail to reject. The confidence interval, what does it tell you? Does that make sense? So your conclusion should specifically talk about those numbers. Does that make sense? Any questions? Any questions about Project 2? Any questions? And you're happy to ask questions on the project discussion forum. Again, do it there. Don't do it by emailing me, because other people could benefit from your questions about the project. What you can do, same rule as before, I will read through your draft once. Don't wait until it's due, because then I'll assume you're turning it in. So again, make sure you send it to me, days before it's due. So you have several days before it's due, so you have time
When would be the
what I
deadline?
wrote and then address the comments.
When would be the deadline for that, for the draft?
Okay, well, let's look at the deadline. Let me get it so I know for sure. So if you go to syllabus, Project 2 is due on March 18th. So you have more than 2 weeks, by the way. Okay, and that's a Sunday. Everything's due on Sunday, basically, in this class, except Thursday discussion posts. And by the way, there's nothing much due today. There's no discussion posts due this week. I wanted you to focus on the midterm and then getting the project started. So that's why it's a very light week in terms of new material. But there is one chapter, the chapter 10, which is not the hardest chapter, but it is one thing to do. So you should get started in the project right away. I strongly recommend you send me project 2 draft at least 5 days before. So like Tuesday, you get to me Wednesday, I can still read it. After that, I may not have time to read it. And you won't have time after I read it to address my suggestions. Because I can guarantee there'll be suggestions, right? There's always stuff you can improve on. If you don't send me a draft, you're not being very smart.
Can I make a comment about your suggestions
Which ones?
on the projects? On the last project, in the project that was submitted, some of the stuff that you wrote on the final, like for the final grade, were not even suggested.
They might have been. Like I said, I'd have to look at it. Sometimes I'll write stuff that's minor, like I'll fix a typo or something, and I don't do that on my suggestions. And that's minor, and you don't lose a lot of points.
It wasn't. It was something major. It was like a major thing, but like it wasn't on the suggestions that you sent.
Right. Sometimes I do the suggestion, you make a change, and you change it wrong. And now there's a new problem. That happens sometimes too. So I'd have to look at it, but that's, I put all the major stuff, but maybe you didn't understand it. That's possible too. The suggestion. Maybe it was a deeper suggestion than you thought.
Okay.
Does that make sense?
Mm-hmm. I just want to make sure that when you are suggesting, you're suggesting all the possible.
Yeah, I'm not always going to do everything, but I'm going to do the major points.
Okay.
I'm not going to list 100 things.
No, I understand that, but like as far as this was something major, and it was not on the suggestions.
Yeah, I'd have to look at it, but what happened.
Uh-huh.
So, yeah, and it depends on. I have to look at the project again and see, but.
Okay.
Yeah.
Thanks.
Other questions? So we're pretty much done with anything new I need to talk about. My guess is next week's webinar will be Monday, because we haven't had Monday in a little while, and people like Mondays. I found the best attendance has been on Monday. But I don't know for sure. I guess I should check my calendar to make sure. That's always important. I have to be there. But I don't think I have anything Monday. Yeah, no. So there's a good chance it's going to be Monday, unless you post in the Q&A forum that you'd rather have it a different day, and there are a bunch of people like it a different day. Other questions? Okay, so again, you know what you need to do. Again, step 1, get a partner. Step 2, get your hypotheses written up on the project discussion forum, and I'll look at it. And then step 3 is collect your data, and then we'll talk from there. Or you can ask questions. Any questions at all, or would you like to say goodnight?
Good night.
All right, good night.
Good night.
And Sean, you've been pretty quiet, but my guess is that's a good night too. All right, good night, Sean. And for those of you who are watching this as an archived YouTube webinar, thanks for watching. Please post on the Q&A forum and for just general questions, and please post on the project discussion forum for project questions, and I'll be happy to answer. So good night.